Hello class, welcome to another class that we are going to discuss reaction of acids, bases. Now, this reaction of acids with bases we are going to discuss here, our 14th lesson. Now what we are going to do here, we have this here. I'm going to take I want to see then we are going to pour the contents here. Let's test tube. This is the base inside here. Our main objective here is to determine the endpoint. We want to take an indicator here. It is called phenol coloring. We want to have some few drops here. Phenol coloring. Now you see, phenol coloring is colorless. But now, if you introduce base, the color changes to pink. Now, this has happened. Now we are going to see the amount that is supposed to make this color change from this pink to another color. Now, the color, the amount, or rather the point at which that color is going to change from whatever this color we have here to another color, that point is going to be called the endpoint. So we are trying to look at the amount of the acid that is going to neutralize. And at that point, when we find that this is going to change the color, we are going to talk of this particular substance being neutralized. So we have sodium hydroxide as the base, then we have hydrochloric acid. And as I initially told you that a base plus an acid should be giving you salt and water. In other words, the kind of neutralization, or rather the reaction we are carrying out here is called a neutralization reaction. So now let's introduce drops of acid. So you have well found that acid is reacting in base. Now you can see clearly the color started changing. The color is changing here. We are expecting to have a colorless solution at the end. As you can see, the color started changing. Now, once we have this kind, now we reach what we call endpoint. An endpoint is only reached on one position when one of the reacting substances has been consumed. So you find that in acid, in base, no coloring is in. But when you introduce acid, after all the bases, or rather the base which was inside has been consumed, the color changes from pink to colors. So that was an example of a neutralization reaction. Measure the limit of dilute sodium hydroxide, which was this one. Solution and put in a clean conical flask. In this case, we used a test tube. Add 2 to 3 drops of phenolphthalein, which is this one indicator. Note the color of the solution. Add diluted hydrochloric acid drop by drop. Here is our dilute hydrochloric acid here. And you add drop by drop using a dropper, or you can also use what we call a burette to do that. Actually, the best way to do it is using a burette and a conical flask and a stand. Count the number of drops until the indicator just changes color. Repeat the value procedure without adding the indicator. Add the same number of drops of hydrochloric acid, 10 mg of sodium hydroxide. Put the resulting solution in an operating dish and heat the solution to saturate it. Allow the saturated solution to cool. Record the observation, what you want to see. Now, another one, you place a small sample of calcium oxide into a test tube. Add dilute nitric acid, shake the mixture. Repeat the procedure using the following: solids, different test tube, zinc oxide, copper 2 oxide, magnesium oxide, and lead 2 oxide. Record the observation in the table below. Use dilute hydrochloric acid instead of dilute nitric acid. So this is your table here, and what you are supposed to observe when that happens. Now, some of these experiments might need some warming so as to make the reaction proceed faster. You just warm gently to make the reaction proceed faster. Warming increases the rate of reaction between the reactors. Therefore, where reaction does not seem to occur, the mixture can be warmed gently. Now, what's happening here? An operator is used to determine the end point, the end of the reaction, known as the end point. For example, now, so the point at which the color changes is called the end point. Indicator is used to indicate the quantity of acid needed to react with 10 mg sodium hydroxide. Now, it's not used in the same experiment. There's a place whereby you're being told this time don't use indicator, because after you determine the amount you really need to obtain the end point, whereby one of the reactors, in this case the acid, is completely going to be consumed, then you don't use it for a second time, because when you use it for that second time, it will be a contaminant. In other words, you're going to contaminate the product. Now, another is pink in basic, as we have already seen, the pink color in basic, and colorless solution returns colorless. For example, what we have here. Now, colorless from pink. When acid reacts with bases, they form two products. Acid reacts with bases to form two products, and these products are salt and water. They form salt and water as the only product. Now, in this kind of reaction, salt and water are neutral products. In other words, they are not going to have any effect. They are not going to have any effect on what we call litmus paper or the indicators. And therefore, since salt and water are kind of neutral, therefore this kind of reaction is called neutralization reaction. Neutralization reaction. So sodium reacts with diluted hydrochloric acid to form two types of the salt, and as you can see, I told you sodium chloride, sodium hydroxide plus hydrochloric acid. Now, from this one, the kind of salt that is formed, you can't predict. We have sodium and chlorine. So this is going to be sodium chloride, which is going to be salt, plus what we call water. When you reach from 2, we're going to learn something. Hydrogen, hydrochloric contains hydrogen, while hydroxide contains what we call hydroxide. So this is a base. Remember when you are dealing with the properties or rather definition of acid and bases, we said a base is a substance that can dissolve in water to give hydroxyl ion as the only negative ion, while acid is the substance that dissociates in water to give hydrogen ion as the only positive ion. So we find that this hydroxyl ion, if you combine it with hydrogen ion, it forms water. In other words, it's something like OH plus H plus. These two form what we call H2O. We have 2 hydrogen here plus water, oxygen is going to form water. Now we are going to take a break at that point, and when we come back, we are going to continue with this discussion. Thank you.